Okay, we're just going to finish this section on surds here with this expanding bracket. It's going to go through some of these examples and hopefully you can get the idea. 5 times 2 is going to give us 10 and the root 3 times root 3 is just going to give us 3. So it's going to be 10 times 3, it's going to be 30, and this one times this one is going to give us minus 20 root 15. Okay, now this one here is a full FOIL, but we notice we've actually got the difference of like the factors of the difference of two squares. So all I know it's going to be this squared minus that squared. So 2 squared is 4, and root 3 squared is 3. This is going to be 4 take 3. It's just going to equal 1. Okay. There's the difference of two squares, the factorization of it. Okay, that should start to look sort of familiar to you fairly soon. This one here, there's a perfect square here, and this requires you to do the FOIL. Now you could sit there and do yourself. I'll just give you the answer here, how this comes out. Well, there it is, the perfect square comes out like that. Okay, so we should be able to use that to get that answer, and ultimately, if you do all the simplifying, it's going to come to that, and finally end up that. So if you work through that on your own, just pause the video, and you should be able to work out just all the simplification of that using that. Okay, rationalizing the denominator, that's the last part of this. This is a process that can be applied to any fraction with surds in the denominator. The aim is to make the denominator surd free or to rationalize the denominator. Key background, multiplication of the form also results in a non-surd. Okay, that's the big issue of this. And these two things are called conjugates. A take B times A plus B, they're conjugate factors. Okay. Okay. Actually, just showing you that there is gives you a surd free. You should be able to see that easy. Okay. Okay. There you go. There's an example. There's two conjugates. Okay. It's just the difference between those two factors is just the plus and the minus. And so this just ends up with root 7 squared, take 2 squared, 7 take 4, which equals 3. Now you could do a complete FOIL thing on this, but you'd find the 2 times root 7 and the minus 2 root 7, those cross terms, they cancel. And all you're left is with the square of these two last terms, which is what you get here. Okay, we should be familiar with that. And this is another one that they've done. Once again, you see the conjugate pairs there. That's 3 root 5 take 9. This is 3 root 5 plus 9. And when we expand that bracket, we just end up with this situation. You end up with minus 36, which is surd free. So whenever you multiply two surds together that are conjugate pairs, you end up with a surd free answer. That's the point they're trying to make. Okay, this is another thing. Any multiplication of okay, non-surd. Those rules you should be able to understand now. Okay, just going to go through a few examples here. Express that with a rational denominator. So let's just see how they've done that. Okay, multiplying by 1, that's okay, we understand that. So if you have a look, they've deliberately chosen root 2 over root 2 because that there is going to get rid of that surd down the bottom. And that's what we mean, a rational denominator, a non-surd denominator. And multiplying something by root 2 over root 2 is the same as multiplying something by 1. So that should be pretty simple how this is going to work. Okay. You'll see there's 2 lots of root 6 on the top, and 5 times root 2 times root 2 is 5 times 2 is 10, And we're going to simplify that, probably. Yeah, that simplifies there, the 2 and the 10. They do some cancelling, they're non-surds. Okay, and you end up with root 6 times 5, divided by 5. Okay, we're doing example 2. Let's have a look how they do this one. Okay, same thing, multiplying by 1, but now they're going to multiply it by this. Now, all of this reading is basically, if you have a look at here and here, we've got 2 conjugate pairs. Okay, that's done deliberately because we know when we multiply 2 conjugate pairs with surds in it, when we expand it all out, it's going to give us a non-surd denominator, and that's what we want, a rational or non-surd denominator. So if we do all the multiplying out here, using the same rules that we've done before, we're going to, and they're showing you there, we're going to actually end up, the top line is going to be 4 root 2 plus 6, can't do anything with that, that's as simple as get, but the bottom ends up as 8 take 9. 8 take 9 is -1, so we're going to end up with that. So you should be able to work out the top line. 2 times 2 root 2 is just 4 root 2, plus 2 times 3 is 6, so 4 root 2 plus 6. But this, we should know now, this is conjugate pairs, it's just going to be this squared, take this squared. Okay, hopefully we're getting that one. Okay, this one, example 3, it's very similar. If you have a look, they're going to, there it is, they multiply this by the conjugate pair. These are conjugate pairs, and of course, this here just is like multiplying it by 1. So this is going to be a bit of a foil here. We'd really nice to put brackets in here. So I think they're going to do that with brackets. Yep, brackets are our friends, as we know. So we need to do the foil here, a bit of mucking around. You should be able to, this one, top one, you're going to have to do the foil. This one you don't have to, it's 2 conjugate pairs. So it ends up just being this squared minus this squared. So I'm going to leave you to do the working out for that one. Just follow what they've done here. The 4 root 3 squared is how we get 48. The 3 root 5 squared is how we get 45. The rest you need to work out yourself. And it's eventually going to come all the way down to this. Sorry, I might have went too far there. We'll just go back. Oh, that's as far as we get, yeah. The numerator contains all unlike terms, therefore can't be simplified further. Okay, but there was the point. We want to rationalise this. We multiply it by, we hit it with a conjugate. There's that conjugate pair, and of course we do multiply by the numerator and the denominator by this. It's equivalent to multiplying it by 1. So it doesn't change its value, it just transforms it into something with a rational or non-surd denominator. Okay, that's the last of the skills that we need to understand and techniques about surds, and that we'll be doing this year.